Hello everyone, and welcome to the Self-Sovereign podcast. We discuss a range of topics related to autonomy and self-empowerment. My name is Justin Smith. For the last 10 years, I've been an independent documentary filmmaker. Our guest today is Professor David Diamond. Professor David Diamond is a renowned neuroscientist and psychology professor at the University of South Florida. Professor Diamond has focused on understanding the role of stress and trauma in the development of mental health disorders, particularly in regards to post-traumatic stress disorder. He has 40 years of experience as a neuroscientist and conducted numerous studies on the neurobiology of stress. He has received a number of awards for his work, and in 2022, Professor Diamond was listed in the top 2% of all scientists by Stanford University. Since 2007, Professor Diamond has been interested in cholesterol, statins, and the real causes of heart disease. His work in this area has led to the publication of a number of important articles. In particular, he has been challenging the idea that LDL cholesterol, so-called bad cholesterol, causes heart disease, and he's also been exposing the statistical manipulations that make us think statins are better than they actually are. In this interview, we do go into quite a lot of detail. I have personally been researching this subject for about 14 years, and I certainly learned something. So I really would encourage you to listen to the whole episode if you can. Okay, so before we get into the topic of cholesterol and heart disease, could you please give us a little background in regards to why you became a scientist and how you became interested in neurobiology and stress?
Sure. So it was about 45 years ago. I was an undergraduate and I was actually looking toward going to medical school. But I learned a bit as an undergraduate about the brain and neuroscience. Volunteered in a laboratory where they were studying the brain and memory, and I became just enthralled with it and decided at that point that I wanted to make my career out of studying the brain. And I've been very fortunate to have 45 years of funding. I was just recently retired from the VA after 30 years, and I was a career scientist there. And it's been really very rewarding because I've been able to study memory-related disorders such as PTSD and Alzheimer's disease. And I've been able to be involved in clinical work in which I think we've really benefited people with either one of these afflictions.
Okay, great. And then what prompted you to take an interest in nutrition, cholesterol, and statin medications?
Sure. So in fact, people ask me, why is a neuroscientist talking about heart disease and cholesterol? So while I was developing my career as a neuroscientist, about 25 years ago, I happened to take a blood test, which was actually to get life insurance. And I was put at the very high risk for life insurance, which really surprised me. But when I looked at the results, I saw that I had astronomically high lipids, a particular one called triglycerides, and that's fat in the blood. When you have very high triglycerides, you actually have really thick blood that's inclined to clot very easily. I also had extremely low, what they call good cholesterol, the HDL. And so in the ideal person with ideal health, your ratio of triglycerides to HDL is typically 1-to-1, maybe 2-to-1. So whatever you're measuring in triglycerides would be about the same number as what you would have with HDL. My triglycerides were 25 times higher than my HDL. And that's why I was put in such a high-risk group. I knew a lot about the brain, but I didn't know much about heart disease or triglycerides. And I really just thought, well, if I just exercise and cut out the fat in my diet, cut out the red meat, I could beat this high triglycerides. And all that happened was about over almost a decade, my triglycerides went higher on my low-fat diet, non-meat diet, exercising, and my weight increased. So I was a good bit overweight at the time. And I finally, when my doctor insisted that I go on medication, including statins, to the medication that lowers cholesterol, I finally decided to put my background in biology to good use. It was almost a decade before I read my first paper about triglycerides, and it suddenly hit me. Triglycerides are produced when we have excess glucose in our blood. The liver converts glucose into triglycerides. And then I had an epiphany in which I had been cutting back on fat when really what I needed to do was cut back on carbohydrates. So this is very personal for me. And then what happened was the more I learned, the more I realized that we've been given the wrong information about cholesterol, that we don't need to fear cholesterol. Really, what we need to fear is the carbohydrates on our plate. And high cholesterol, I learned as I studied the literature on my own, does not cause heart disease. I decided to have a seminar at my university, University of South Florida. And I started sharing this information with the students. And this was about 12 years ago. I happened to give a talk to the public on what I had found about cholesterol and diet. And I wasn't even aware of it at the time, but the talk was recorded and put on the internet. And before I knew it, there were hundreds of thousands of views of my talk, which then led to the talk not only went viral, but my interest in cholesterol went viral. People contacted me. They started requesting that I come to conferences. I've been invited to speak at conferences now around the world. I've been to Saudi Arabia twice, been to Europe, I've been to Africa. And so I gave talks. And then I started publishing papers. I'm working with clinicians, and I've been publishing papers about cholesterol. I've published out a dozen papers now. And in fact, I'm still a neuroscientist. I still work on neuroscience projects, but I consider this now my second career, which is to publish papers on what I see as the real science of cholesterol and heart disease.
And what basic proportions of your time are you now spending on the cholesterol and statins research and the neurobiology?
I would have to say I've been devoting far more of my time toward cholesterol, heart disease, and diet than neuroscience. I still collaborate with people. In fact, I'm on a grant right now, a proposal to which is exclusively about the brain and the hippocampus, the memory center. I'm still very interested in PTSD and Alzheimer's disease. But I would say that as far as my real publishing work, the time I spend on a daily basis now is on cholesterol, because it's really challenging all the different levels at which, frankly, I think cholesterol is misunderstood, and there is outright deception in this field. So I feel like I have to be an expert on all aspects of cholesterol to truly understand how it is that we're being deceived about the demonization of cholesterol.
And that dramatic shift in how you allocate your time, is that a result of being very surprised in regards to what you found when you started to look into the subject of cholesterol and the real causes of heart disease? I know in my own personal experience, when I started to look into it, I was nothing less than really shocked to find that the majority of the medical establishment had got something so fundamentally important so wrong.
So, as I said, I've been a neuroscientist for 45 years, and it's really been a career without any controversy. I study the basic mechanisms of memory. I study people who have been traumatized or people who have Alzheimer's disease. And I've been well funded by drug companies in my neuroscience research. And there was no controversy in my neuroscience studies. And I was just, as you say, shocked. And that's a really good way to describe it. When I saw the manipulation of the data in the cholesterol research. And I think it's because I am so shocked. I am so, frankly, angered at how we have been deceived with the cholesterol research, that it perhaps gives me a bit more motivation to want to pursue this area. I find it very gratifying, too, that I have so many people, not only lay people, but I have MDs and PhDs coming to me and who want to work with me and to get that message out.
And obviously many people are still fearful of cholesterol and fearful of their cholesterol level. What would you say to those people?
Well, first, we do need to be clear that I'm not a physician and we are not giving any medical advice. So I certainly am not telling anyone to stop their medication. And frankly, that's solely for litigious reasons. We need to be concerned for that reason. Therefore, this is not medical advice. But what I have learned is that this fear of cholesterol goes back almost a century when it was discovered that people who have extremely high cholesterol from birth, and this is because of an anomaly in which the cholesterol receptor, specifically the LDL, low density lipoprotein receptor, is very inefficient in these people. And because of that, their cholesterol levels are extremely high, 2, 3, 4 times what's considered normal. And what they found was that when people, even quite young, could have heart attacks. So these are people who have high cholesterol, and there's cholesterol actually in the artery, in the plaque. And they made the valid assumption that that high cholesterol in the blood goes into the artery, clogs up the artery, and kills these people. And the real problem is that cholesterol became such a focus, it became so demonized, that people have been reluctant to get beyond that point. And there are associations between high cholesterol and heart disease, particularly in young people and middle-aged people. You don't see much of an association of cholesterol heart disease in older people, which frankly really should raise a red flag. It doesn't make much sense to say that cholesterol is associated with heart disease in young people, but not elderly people. And so that's sort of, to me, a very important message to get across, that these people, in fact, it's called familial hypercholesterolemia, these people actually don't have more heart disease as they age, and they have no greater rate of stroke. And of course, that makes absolutely no sense if you live an entire life with very high cholesterol. And that's what has led me to say, well, it's not cholesterol that's causing heart disease.
And could you briefly talk about what cholesterol is actually needed for within the body?
So cholesterol is an absolutely crucial molecule. It can be considered sort of the mother molecule of so many different hormones that we need in our body. For example, cholesterol is converted into all the sex steroids. Without cholesterol, you couldn't make estrogen or testosterone. Cholesterol in the skin is converted into vitamin D. So anything that is derived as a steroid, all the steroids are derived from cholesterol. We would die without sufficient cholesterol. So it's an absolutely essential molecule used in every cell in order to have normal metabolism.
And some people are still avoiding foods that contain cholesterol. Do you think it's necessary to avoid foods that contain cholesterol?
So here is what's important about sort of my message. I grew up with the idea that eating meat was potentially unhealthy. I used to eat veggie burgers. I limited my red meat consumption. And it really was only as I took an objective view of the literature that I realized that this is called the diet-heart hypothesis. And it was begun, 50, 70 years ago, 60, 70 years ago. It was promoted by someone named Ansel Keys, who really knew very little about heart disease and diet, but he was a very powerful figure. And so it's been promoted that the idea that it's not just cholesterol, but it's also saturated fat. So overall, we're really talking about, in fact, Ansel Keys didn't say consuming cholesterol will raise your cholesterol. He actually said consuming saturated fat, which is animal fat, will raise your cholesterol. It's really quite odd, since cholesterol is only found in animal products, and saturated fat is primarily found in animal products and as well as tropical oils. So the idea is that when you consume saturated fat, you will raise your cholesterol, and when you raise your cholesterol, you have a heart attack. And this is clearly wrong. It's been shown to be wrong in so many different levels of studies, and yet it's still promoted by organizations such as the American Heart Association, which warns people against consuming saturated fat, and they still promote the diet-heart hypothesis. And it's antiquated science. It's been proven incorrect. It's been promoted largely by vegetarian science. Cardiologists seem to also believe in it. You see now with the great promotion of vegetarian foods, in which they're very focused on the amount of saturated fat in the food. And so there are different approaches that want to demonize the saturated fat. And yet, when you look at populations in which people do consume high percent of saturated fat, in fact, in Western world, the French consume the highest percent of saturated fat of any European nation in their diet, as well as the U.S. and they have an incredibly low rate of heart disease. So it's simply a hypothesis that failed, and it's simply remaining. But there's no reason to believe that saturated fat or consuming cholesterol has any adverse effects on your health.
My understanding also is that those early studies that were done by Ansel Keys were found to be fraudulent, in that he famously plotted the graph with taking data from the 6 or 7 countries to produce a nice straight line correlation. But in reality, he had data for 22 countries, and if he plotted all of the data points, then there wouldn't be any correlation at all.
Yeah, that's very correct. So Ansel Keys had data from 22 countries, in which this is called epidemiology. And you're looking at what are people consuming in countries. And this is really a flawed way to look at science anyway. But you have, what were people eating soon after World War II? And so, yes, indeed, he had data from 22 countries. He selected 6 data points, which made basically a straight line in which increased consumption of, actually it was fat at the time. He started off just demonizing fat, and then he evolved into demonizing saturated fat. But yes, and it's amazing to me that there are apologists out there. They say, well, Ansel Keys took the most reliable data. Well, who gets to decide what's the most reliable data? So clearly it was fraudulent. This was the 1953 paper of his. He did follow that up with what's called the 7-country study. And so this is clearly also a biased study in which you're looking at different countries around the world. And you're seeing what do they eat and what are their rates of heart disease. And it's famously pointed out that he disregarded the people of France. They weren't included in his study. He didn't include the people of Switzerland, both of which have an extremely high saturated fat diet. We're talking about the percent of fat, of saturated fat. We're not saying that these people are eating bacon, and ham all day long. What actually naturally happens is when you consume fat and protein, it has a natural satiety effect. And so, in fact, when you look at the people of Switzerland, for example, and France, what they're actually doing is they're eating less total calories than what you have in the U.S., where we have more of a carb-based kind of diet. But the point is that Keys clearly wanted his study to demonize fat in general and specifically saturated fat. And his work is now seen as quite unreliable.
Okay. And has the definition of high cholesterol changed over time?
Yes, what has happened is decades ago, and I've seen people who are physicians have talked about how the threshold for high cholesterol used to be 250 milligrams per deciliter. That's in our terminology. And it's been lowered over the years until now it's so amazingly low that the vast majority of people now have what's called high cholesterol. So now the threshold is considered a total cholesterol of 200 milligrams per deciliter, which in fact, the majority of people have high cholesterol according to that threshold. The LDL as well. And so what you find is the threshold for LDL has been lowered to near zero. Used to be 120 was good, then it was 100. Now what they're saying is LDL should get below 70, and almost nobody has LDL below 70 without taking medication. And this is without a doubt. This is the influence of the pharmaceutical industry. Because as you lower these thresholds, what happens is more and more people now are become eligible to have to take medications such as the statins and some of the newer medications. So this is just, to me, an egregious example of the intrusion of the pharmaceutical industry into standard of care as far as guidance for people for optimal heart disease parameters.
And so the model that we are led to believe, of course, is that the total cholesterol level and the LDL level should be low and the HDL level should be high. So which aspects of that model are actually true and correct?
Well, this is actually, it's a good question, complicated answer. So when we talk about LDL, what we need to understand is that there are multiple components that make up when we talk about cholesterol, when we talk about LDL. So total cholesterol is absolutely near useless. There are so many different components that make up total cholesterol, and it's clearly been shown to be unrelated to heart disease, despite the ability of the anti-cholesterol people, we call it the war on cholesterol, despite their approach to demonize cholesterol, there really is no relation of total cholesterol to heart disease. But LDL is one component of total cholesterol. HDL is also one component of total cholesterol. This is part of the problem. HDL increases when basically people are healthy. People, when they exercise, they have low blood sugar, they have higher HDL. And that's why it's called the good cholesterol, because higher HDL is associated with less heart disease. But, I point out to people, well, higher HDL is also associated with people more healthy. And so people who exercise and aren't overweight have higher HDL and they have less heart disease. So there's no real cause and effect with HDL. LDL is called the bad cholesterol. Now, LDL is made up of different components as well. So with LDL, and that's really the total cholesterol and all the LDL particles. You can think of LDL as sort of a carrier. And think of it, the LDL particle is a bit like, I think of it as an M&M. It's got a coating, and then there's an inside. So the coating is a protein, and inside the chocolate would be equivalent to the cholesterol that's inside. And this is really important, the way to think about it, because cholesterol is basically a fatty substance, and the blood is basically water. And so fat doesn't dissolve in water. And so that's the purpose of this lipoprotein. The cholesterol is encased in a protein coat, which allows it then to travel in the blood. Well, these pellets, these particles of LDL have different sizes. And this is so incredibly important. When you are healthy, okay, again, meaning low, you don't have hypertension, you don't have high blood sugar, and you exercise, the LDL particles tend to be very large. And that is not associated at all with heart disease. But in someone that's hypertensive and high blood sugar, that causes the liver then to convert that blood sugar to triglycerides. Triglycerides then get encased in the LDL particle, and that causes it to be extremely dense. And when people have a high concentration of this dense LDL particles, well, they're much more likely to have a heart attack. So now the question is, does the dense LDL cause the heart attack? The answer is no. The dense LDL particles, the small dense LDL particles, are found in people who are hypertensive, who have high blood sugar, and who smoke, and who are overweight. So what we need to think about is how sometimes the metabolism is like a burning building. And as you go through that burning building, you're going to see different rooms that will be on fire. One of the rooms on fire is the LDL. It's actually damaged by having all this high blood sugar. This is why it's so foolish to be talking about total cholesterol or total LDL. You need to understand how there are different kinds of LDL and they reflect your metabolism. So the small dense LDL does not exist by itself, and it does not cause heart disease. It's that damaged metabolism that so many people have now because we're overweight. We have the high triglycerides and the high blood sugar and the high blood pressure. That's what contributes to the heart disease.
I also find it fascinating and extremely disappointing at the same time that it's not talked about that the LDLs and HDLs carry other important nutrients around the body as well. That obviously they're the transport mechanism for coenzyme Q10 and beta-carotene and vitamin E and other nutrients.
Yeah, that's completely ignored. That it's basically an energy and nutrient transport system. People just really focus just on saying that the LDL particle itself actually causes, and the mechanism has never been well shown. This idea that as the LDL concentration is higher, that somehow it's either transported or just seeps into the artery wall and then wreaks havoc and produces a plaque. And that's simply not been supported.
And it's disappointing to me also that the other reasons that can cause cholesterol levels to be altered are seldom looked at. I understand that when stress levels are high, our cholesterol levels are higher as well, and that when someone has a low thyroid function, that can also lead to a higher cholesterol level. Is that correct?
Yeah, so any change in metabolism can have a dramatic effect on cholesterol. Cholesterol is very sensitive to the immune system. Cholesterol is, in fact, part of the immune system. So in fact, when there is an invasion, a pathogen invasion, the cholesterol is actually used to attack the invader. You actually see LDL binding to pathogens. And in fact, what happens is cholesterol drops precipitously when we have a severe infection, because its job is to work with the white blood cells to attack the pathogens and to remove them from the body. Now, the problem is, as our cholesterol drops, because it's involved in that immune response, then people actually become more susceptible to dying of infection because they have insufficient cholesterol. What's really fascinating to me is that the people who are enabled to have extremely high cholesterol is they have a far more efficient immune system. And so the elderly people, and we're talking people in their 60s, 70s, and 80s, who have extremely high cholesterol have a significantly lower rate of cancer and on non-cardiovascular disease deaths and a normal rate of cardiovascular disease. So having that high cholesterol is protective. Cholesterol's role is to work with the immune system to eliminate cells that are unhealthy.
You briefly mentioned familial hypercholesterolemia earlier. Could you briefly explain what that condition is, and if the early studies done on that condition were kind of used to support the cholesterol hypothesis for the general population?
So this is a very rare disorder in which the LDL receptor is quite inefficient. So the job of the LDL receptor is to grab onto cholesterol in the blood and then bring it into the cells where the LDL then can provide energy and nutrients. And so for these people, the LDL receptor is very inefficient. Now, the way I look at it is cholesterol is so incredibly important that because the receptor is inefficient, the liver ramps up its cholesterol level. So if you've got a receptor that is 30 or 40% efficient at bringing in cholesterol, the liver ramps up our total cholesterol in these people to increase 2 or 3 or 4 times as much in the blood. That way, you actually end up getting cholesterol going into the cells. So that's the reason why I say these people have very high cholesterol. And this is relatively rare. It's estimated about 1 in every 200 to 300 people will have this disorder. Now, getting back to it, though, what you do find is when people have a heart attack quite young, you do tend to find that it's the people who are diagnosed with familial hypercholesterolemia. So someone in his 20s or 30s who has a heart attack, dies of cholesterol, will have this disorder. And as I mentioned earlier, it's quite logical then to say, well, it must have been the high cholesterol that seeped into this person's arteries and caused a clogging of the arteries. And that's basically the dogma that began almost a century ago. There's a problem with that. The real problem with that is if it's so simple that LDL simply seeps into the artery, develops a plaque, and over the years builds and builds until ultimately it chokes off the artery, then frankly, everyone with FH should be dying young. I mean, there's just no room for any alternative outcome. The surprising thing, and I publish this, I present this, and this has actually been published by people who are statin advocates. So this is real science that has shown, first of all, the overall all-cause mortality, that is the rate of death of people confirmed to have FH, is no different from the general population overall. And to make this even more intriguing, for elderly people who have lived their entire lives with extremely high LDL cholesterol, they have in their 70s, for example, in that decade of their 70s, about a 40% lower rate of death. I'll repeat that. They have a 40% lower rate of death compared to the general population. And this just simply makes no sense whatsoever if they've lived a lifetime with this toxic agent in their blood. And so this is why I've said in familial hypercholesterolemia, yes, you do have people with very high cholesterol. You do have a subset of these people that do have heart attacks when they're relatively young. And so what I've done with my work and with some outstanding people. And I want to emphasize, I've been led by Ufi Ravitskov, who I think has been one of the leaders in this field, and I've worked with him. And we published papers to show that the reason why the subset of people with FH die young is not because of their cholesterol, it's because they have a second anomaly, which is largely ignored. That second anomaly is they have abnormally high clotting factors, such as fibrinogen, or it's called factor VIII. And so, and overall, people with FH have more viscous blood. And so people with greater viscosity are more likely to have a heart attack young. That viscosity has been confirmed that it is not the cholesterol causing it to be more viscous. It is the clotting factors, such as fibrinogen. And this has been documented over decades, and there are a massive number of papers, and it's been completely ignored by your guideline committees. American Heart Association doesn't mention fibrinogen once when they're talking about the research on familial hypercholesterolemia. And we published now a couple of papers reviewing the research on, I'll call it FH, showing that the studies that have actually looked at what is associated with heart disease and FH, and it's very clear that it's not LDL, that it's both excess coagulation factors, clotting factors, such as fibrinogen, but it's also insufficient what's called fibrinolysis. When you make clots, and this is part of my stress work, when we get angry or we get stressed, we quite literally have clots in our blood. Our blood is preparing for a hemorrhage. And so it's as if our body interprets anger and hostility as being there's a predator chasing us. In anticipation of that wound occurring, our blood already starts to clot. And so that stress produces clots. After that, we have to break up those clots, and that's called fibrinolysis. And so the people with FH not only have enhanced clotting capacity, they have insufficient fibrinolysis. And this is in this subset of people that are more likely then to have the heart attacks when they're young.
And the correlation between higher cholesterol levels and increased life expectancy is something that we particularly see in the elderly as well. Is that correct?
That's correct. So this has actually been documented at different levels. It was first documented in the 1960s. Really nice study of over 1,000 people, looking at their age, their metabolism, and seeing that basically they're representative of the general population. And the point is not greater longevity, but from the lifespan, from birth, what you see is no difference in overall lifespan of people with FH. Now, the great advantage that people with FH have is as they get older. So as elderly people are dying not only of heart disease, but also of cancer and non-cardiovascular disease, the FH people are not dying of cancer and non-cardiovascular disease, and they have a normal rate of cardiovascular death, which is why overall, after the age of 60, you start to see that these people have a lower rate of death compared to the rest of the population. And in fact, a genealogical study looking back to the 20th century into the 19th century indicated that the people with FH were protected in the 19th century from infectious disease death. And so they lived longer than the general population. So again, that gets to LDL being so incredibly important as a part of the immune system.
I think you've briefly touched on this already, but could you discuss in a bit more detail the actual mechanisms involved in the progression of heart disease and how your view of that process differs from the conventional view?
So the conventional view is quite simple. The idea is that there's sort of a concentration gradient in which LDL seeps into the artery wall, triggers an immune response. The LDL gets oxidized. It gets engulfed by monocytes or white blood cells. That further triggers greater inflammation. More LDL comes into the artery wall, creating this plaque. The plaque then grows over the years. Repeatedly, this happens until eventually that plaque becomes so large that it either blocks the artery, causing a heart attack, or it erupts into the blood vessel, triggering a massive clotting response and inflammation response, which also can cause someone to die. That is the standard view. And again, that simply makes no sense, as I said, because you would simply see a clear linear association between cholesterol and death. In fact, you'd see it all-cause mortality, and you don't see that. And again, it makes no sense that you have people in their 80s and 90s with extremely high cholesterol, and yet they don't have heart disease. The alternative way to look at this is to look at our lifestyle, look at the food we're consuming, look at the exercise that we have or we don't have, and we see how does that affect the membranes of the arteries. So when we have hypertension, in particular, stress causes this rapid increase in blood pressure, which then stretches the artery. And if you have at the same time high blood sugar, which then damages proteins. So in fact, most people now are becoming aware of the HbA1c, which is a measure of blood sugar, but it's really the measure of blood sugar, the glucose that has been bound to hemoglobin. And what happens is when the glucose binds to the hemoglobin, it actually damages it. When glucose, and this is kind of interesting that most reactions in the body require an enzyme to occur. Glucose literally can attach itself to a molecule, interfering with the function of that molecule. So glucose attaches to a hemoglobin molecule, and that molecule is essential for enabling us to carry oxygen through the body. And so when we have high blood sugar, which frankly, even if someone isn't diabetic, with the kind of meals that we consume, we get this huge spike of blood sugar that can occur. You know, you have a breakfast of toast and cereal and orange juice, you have a massive spiking of blood sugar, which then interferes with the functioning of cells throughout the body with our red blood cells, triggers a clotting response, and initiates a damage to our artery wall. Repeat that process often enough, and you now therefore gain access into the artery wall of pathogens, for example. There's good evidence that infection is a part of the problem with heart disease. What you do is you find remnants of bacteria and viruses that are in the plaques, so they're able to gain access to the artery wall. What you also have is the artery wall is so incredibly thick that you can't just be able to oxygenate it with the blood that's in the arteries. The artery wall has its own mini arteries called the vasa vasorum and its own mini blood vessel system. And so as the blood gets thick because of stress, because of high blood sugar, you have actually a blockage of this vasa vasorum. Well, think about it. If you have interfered with the blood flow within the artery wall, well, then that's going to cause what's called necrosis. And so inside the artery wall, you now have damage. And so there is sufficient evidence. This is from animal studies, as well as looking at where does the atherosclerosis, that's the beginning of the plaque, where does it start? And it actually starts inside the artery wall. And I think this is a clue, and I've lectured on this, that when you have blockage of the vasa vasorum, which is inside the artery wall, then that tissue starts to die. And you repeat this process over and over decades, and the inside of the artery wall gets damaged. The LDL, we need to understand, LDL is part of the healing process. It's part of producing a wound inside there. And think of it, LDL, as like you have a hole in your wall, and you patch that wall with spackle. Well, LDL is like the spackle that we have filling in the hole. It makes no sense to blame the spackle for the hole in the wall. And so in the same way then, what happens is over and over, there is damage inside the artery wall as well as at the endothelium, which is the border between the artery and the blood. With repeated damage to the artery wall, ultimately you have invasion of pathogens, you have white blood cells that gain access, and you have LDL that then gains access into the artery wall to repair it. And that to me just simply is far more logical, and that explains why high LDL alone is not associated with heart disease, because it's not simply passively diffusing into the artery wall. That makes no sense, but it is there as a result of damage.
And is it the case that some of the aspects of this alternative model were described even going back to the 1860s and 1870s by, I think it was Rokitansky?
That's correct. So Rokitansky was a pathologist in the 19th century, and he studied the plaques of individuals who had died of heart disease. And he came up with what's called the thrombogenic hypothesis, which is that he noticed how similar the plaques were to wounds and to a clot. And so his idea was that as a result of the damage to the artery wall, within the artery wall, that there were these clots. He didn't actually quite have a mechanism for how it was that you can have a clot inside the artery wall. And that's what I'm suggesting, and I find very appealing, the idea that blockage of the vasa vasorum can lead to this clot formation inside the artery wall. So yes, the thrombogenic hypothesis has been around for well over a century, a couple centuries, and I think it's not been found to be very appealing, because the lipid hypothesis is far more appealing, especially with, as I've said, the domination of the pharmaceutical industry and how this research is conducted.
And you've mentioned how blood glucose levels are related to heart disease. Are there any other nutritional factors that are related to the genuine mechanism involved in heart disease?
Well, blood glucose, as far as nutritional factors, I think is the one that's been studied the most. And I think there's been insufficient appreciation for how vegetable oil has an adverse effect on our health overall. And so what you do see is an association of the increased use of vegetable oil. And it's funny, you call it vegetable oil, and it sounds so benign, but it's really highly organically expressed oil that it is so extraordinarily unhealthy. We know that the trans fats, for example, and what happens related to the vegetable oils is the trans fats were these vegetable oils, such as corn oil or safflower oil. What you do is you literally change the molecule into something that was never existed in this world before. And that way you can make corn oil, which is liquid at room temperature, then you turn it into something solid, which was so convenient. So there is a clear association then for this form of oil, the solidified vegetable oil, which was used as margarine in the first half of the 20th century, and you still have some solidified corn and vegetable oil. Now that the evidence is pretty strong, and you're seeing much less in the way of trans fats, in which you have solid oil. But I think that there's an association as well of vegetable oil in general. In particular, I mean, I think there's some really unpopular approach, but I think it's very likely, are these deep fried oils. So when you take vegetable oil, such as corn oil or peanut oil or safflower, and you superheat it, and you make, frankly, to me, the best tasting toxin that there is. These superheated oils will make fried chicken and French fries, which taste absolutely scrumptious, but they are frankly poison. And what's happened is the oil, because it's been heated, now becomes rancid. It becomes oxidized. And especially when you're talking about adding that to potato, which potato is also going to increase your blood sugar, and potato has what's called anti-nutrients, which potentially can be harmful as well. And so I believe that it is likely that this is extraordinarily unhealthy, but there's just not a lot of funding that out there to be able to show that deep fried foods are unhealthy. So we begin with the clear evidence that the trans fats, that solidified margarine, is clearly unhealthy. We know that. The deep fried oils, clearly unhealthy, because that rancid oil now becomes incorporated into our blood vessels, into our cells. So clearly, I think when you're looking at high temperature cooking, what you want is a saturated fat, such as animal fat or tropical oils, and they're much more resistant to becoming rancid or oxidized when they're heated.
Sorry, did you say that potatoes have anti-nutrients in them?
Yeah, so what you have is now a study, and it's extensive, decades of study, that have shown that plants have strategies so as, in essence, to have animals avoid eating them. Plants, in general, don't want to be eaten. And so since they can't run away, what they have are called anti-nutrients. And these anti-nutrients can make an animal sick. They often taste bitter, or they can be hidden. So you typically find these anti-nutrients in the roots or the stems or the leaves of plants. And plants are quite manipulative, actually. They make the part that they want you to eat, they make it very colorful and they fill it with sugar. And that's the fruit, as well as the flowers. So plants want animals to consume their fruit and flowers because that way they will consume their seeds and then deposit those seeds later on in their feces. And so plants will manipulate animals in that way. Now, what they also have, though, are it's called anti-nutrients, such as called phytates and oxalates, in which what these can do is they can bind to minerals. So, for example, your anti-nutrients will bind to calcium and bind to magnesium in our gut and significantly reduce the availability of calcium, magnesium, and zinc. And so we need to understand this idea that plants are so healthy is clearly not correct. We are actually consuming parts of the plant that it does not want us to consume. And that's why it has put certain chemicals in there to make the animal sick. The other thing to realize when I talk about the anti-nutrients, they're not only designed to make animals sick. Now, for example, plants have a way of binding to the calcium and magnesium because they need it for their growth. And they have enzymes that then free up that calcium just at the right time when they need it to grow. But we don't have those enzymes. And so when we consume the plants, that'll then bind up our calcium and magnesium. We don't have the enzyme that then frees up the calcium, magnesium, or the zinc.
That's really interesting. So moving on to statins now. Do we know how many people take statins around the world?
The estimates that I have seen are frankly frightening. That we're seeing, it looks like almost half of all adults are now being put on statins. And I see that's frightening because first, there's no justification for people to be put on statins. And second, I think the adverse effects are frightening as well. But it's being promoted as being totally benign at worst, that there are no real side effects to be concerned about. You'll see this from the American Heart Association. And doctors have been given this impression that everyone can benefit from a statin, even someone that doesn't have high cholesterol. And the adverse effects have been largely ignored or minimized.
So who does benefit from taking a statin medication?
So that's a complicated question because we actually just published a paper evaluating the statin literature, and we actually showed that there was a study, it was actually published decades ago, that reported a substantial reduction in heart attacks and stroke in people who are very unhealthy. And so what we're talking about would be people, frankly, who were like me 25 years ago. People with high triglycerides and low HDL, kind of people who are overweight, have high blood sugar. You actually do find a substantial benefit of statins in these people. And we contrasted that with people that have low triglycerides and high HDL, which would be more like someone like myself now, or someone on a low-carb diet, someone who exercises. And there was no statin benefit in the people who had the low triglycerides, high HDL. And yet their LDL was equivalent. There's no statistical difference in their LDL. So now the question is, first, why is it that statins do actually benefit some people? And now the question is, well, what should you do about it? So statins are actually what we call dirty drugs. They have actually multiple effects. They don't just lower cholesterol. They have quite a few effects. Two of the most important effects, statins reduce inflammation and they reduce clotting. So, there's actually kind of interesting papers showing reduced clotting in people under stress. And we know that the stress triggers clotting. So if you're talking about someone that has high blood sugar and high triglycerides, the statins will actually reduce that person's incidence of heart attacks. So now the question is, well, if you're overweight and you have high triglycerides and high blood sugar, high blood pressure, just take a statin. Sure, why not? And there will be a lower rate of heart attacks in that person. And again, the reason is not because of lowering cholesterol, it's because they have less clotting. The problem is that statins do have side effects. Statins can access the brain. The brain actually makes its own cholesterol. And when it makes that cholesterol, it uses it to be able to make new brain cells and new synapses, enable people to make memory. And so there's a clear adverse effect of statins on memory. There's a very well-established effect of statins to reduce diabetes. The nicest study I have seen, which was ignored by the American Heart Association in their review, was one out of Scandinavia, in which they found spontaneously in healthy people, about 5% of the people over 6 years developed type 2 diabetes. And about 11%, it was actually 5% of the people without statins developed diabetes, and about 10% of the people on the statins developed diabetes. So you're looking at that additional 5% of people that now are increasing their risk of developing not only heart disease, but also cancer and Alzheimer's, and you name it, other diseases. So sure, you might have fewer heart attacks by not having to exercise or change your diet, but you are increasing your cancer risk and your risk of developing dementia. So I think that needs to be taken into account when you're talking about any benefit of statins, which clearly is offset by the side effects. And of course, you have the joint pain and the muscle pain and kidney problems as well, which we've documented.
So the population of people that you're describing in that study, would they be classified as secondary prevention or primary prevention?
Oh, those were, I believe that was in Norway. It was some Scandinavian country, and these were healthy people. So it was actually a random group of people, and a very large number of people. Now, as I recall, the people that developed diabetes were already susceptible to developing diabetes. So they were not the healthiest people. So these were people that were not formally diagnosed with diabetes. So you could have someone with somewhat elevated blood sugar, but not technically having diabetes. And that was the population that was in the 5% that developed it on the placebo and in the 10%. So they were largely equivalent. And this actually, I'm really glad you raised this point. This is a group that was equivalent at the beginning of the study, equivalent in the sense that they had somewhat higher blood sugar, but not formally diagnosed as diabetes. So these were the people that were vulnerable to develop diabetes. And so 5% of them did develop the diabetes on the placebo, and 10% developed the diabetes on the statin.
And do you recall if in that study there was an increase in life expectancy for the people who took the statin? So was there a benefit in terms of all-cause mortality?
Yeah, so it's a great question in general when you're talking about all-cause mortality. And first, you need to realize that most studies have relatively young, or we would say mid-age people. It's very rare to conduct a study in which people are near dying, near death. You know, the heart disease studies really contrast with cancer studies, in which you do have a high rate of death when you're studying people with cancer. In most heart disease studies, other than heart failure, in which you do have a high rate of death, in most studies, death is actually relatively rare. And so it's difficult actually to talk about a change in all-cause mortality. It's rare in which any more than 1 or 2% of the people die. And so in that study, which was a 6-year study in middle-aged people, death was extremely rare. So the statins did not have any effect on overall death or even cardiovascular death.
Okay. And what kind of can we quantify the benefit that the people received in terms of reducing their cardiovascular disease risk?
So now you're actually leading toward when we talk about absolute benefit versus relative benefit. And this is where I have been outraged. And Ufi Ravinskov and I published a paper on our outrage. So when you hear that a medication can reduce the rate of death by 50%, it sounds very impressive. And there are studies that have shown that physicians and lay people think that, well, half of all the people now are going to be protected from having a heart attack. And it's anything but. So I like to say when I lecture on this that people are terribly uncooperative. Almost nobody dies. And yet death can be reduced by 50%. And how do you do that? And so in a typical study, and I'll give you all pretty close to some real data. Here's a Crestor study, which we talk about heart attacks, in which the Paul Ritker, the principal investigator of the study, talks about how heart attacks were reduced by 50%. And yet, less than 1% of all people had a heart attack. So the two numbers don't fit very well together. You would think it would be like 80% would have a heart attack in the placebo group and 40% would have it in the drug-treated group. That's, 50%. But in fact, what you have in the Crestor study, for example, this is representative of the statin studies in general, about 0.7% of the people on placebo had a heart attack, less than 1%. 0.35% of the people on the Crestor had a heart attack. So we're talking about minuscule numbers. And they had about 20,000 people in the study to bring out an effect. So the real difference in heart attacks between drug-treated and placebo group was 0.35%. There's about 27 people difference in the two groups in about 20,000 people in the study. So how can it be that they say that statin reduces heart attacks by 50%? Well, 0.35 is 50% of 0.7%. And this is what I think is outrageous. And when I present this, I've been invited to speak at cardiology meetings and other medical meetings. And when I show this to the physicians, they're truly astounded. They had no idea that the actual rate, this is called the absolute risk benefit, is so incredibly small. And how you don't hear about this when you go to a typical medical conference. You hear about the 50%, but you don't hear about the 0.35% difference. So the real benefit of statins in most studies is minuscule. It's typically on the order of about 1% when you're looking at population effects.
I think that most people would be really shocked to learn that that exaggerated percentage, the relative percentage, how the system is kind of constructed such that that figure gets propagated throughout the whole of the medical literature and all of the conferences and the drug reps that go and see the doctors. And it's really incredible that even doctors can be misled by that number.
It is quite universal. You see across different approaches, different diseases and afflictions, when you hear of a treatment having X% benefit, you really need to know what's the real benefit. And so you need to know the absolute risk benefit, not the relative risk. And, another way of thinking about this is, if you got a 1 in a million chance of winning the lottery, well, you can double your chances simply by buying 2 tickets. By going from 1 to 2 is doubling, but it's still a difference of only 1 in a million. And that's another way of thinking absolute and relative risk differences.
And you previously talked about some of the adverse effects, the side effects of statins. Do those side effects relate to the parts of the body that require more cholesterol as part of basic physiology?
Well, it's a good question, but my answer would be that every organ requires cholesterol. Every single cell requires cholesterol. Every single cell, especially our muscles, require CoQ10. And when the statin interferes with the HMG-CoA enzyme, which interferes with production of cholesterol, it also interferes with production of other molecules we need, such as coenzyme Q, which is really important for muscle functioning. It's important for heart functioning, which is a muscle. And so this is why you see damage to muscles. People are much more likely to have muscle damage when they're on statins. And I mentioned about the brain. It's really fascinating. The brain actually is isolated from blood cholesterol. The cholesterol in the blood doesn't get into the brain. It has what's called a blood-brain barrier. So the brain produces its own cholesterol. And now the statins, we published a paper that not every statin can get into the brain. Lipitor is one of the best statins at being able to get through this blood-brain barrier. And so Lipitor has been found to have the most cognitive impairing effects. The reason being that the brain needs that cholesterol, it produces cholesterol. And so the Lipitor interferes with the production of cholesterol within the brain. And with less cholesterol, the brain is less able to make new brain cells, new synapses, as impaired at producing new memories. And there's I think, a frightening study that's been entirely ignored, frankly, other than my presentations and our publications. It's been entirely ignored a decade ago. What clinicians found was that they had a rather substantial number of people who were 75 years of age, men and women, all diagnosed with dementia, all of whom were on a statin of some kind. And as a part of the experiment, they took these people off of their statin, explicitly measuring their cholesterol and confirming that they stopped taking the statin. And after about 6 weeks, they tested their memory again, and overall, the group was no longer diagnosed with dementia. The dementia disappeared. And the critical test was that each person was now put back on the statin. And once again, they all had dementia. And this is so incredibly important because we're looking at an epidemic of dementia, an epidemic of Alzheimer's disease, and we have a high percentage of our elderly population on statins. So the question is, how much of this Alzheimer's epidemic is being caused by the brain being starved of cholesterol as a result of statin use? And there is no answer for this because it would appear no one really wants to study this. There's that lone study from a decade ago that was perhaps the best evidence. There is also reporting adverse events. Lipitor by far has the most adverse cognitive adverse events. And this is largely ignored. And again, there's a review by the American Heart Association that didn't even cite that paper from 10 years ago. And there was nothing methodologically flawed about that paper. And so it is something that I find very disturbing, is that now this widespread use of statins is potentially very much related to the dementia. But let's also look at this epidemic of heart failure. And so we know the statins interfere with muscle function. So potentially we're looking at an increase in heart failure, which has not been studied in relation to statin use. So I think the adverse effects are far more widespread than is reported. And it's called statin intolerance. So when people have intolerance to one statin, they're just put on another statin.
I was planning to ask you if the adverse effects have been played down overall, and because of course we know that the commercial interests would not be there to properly study the adverse effects of statins.
Yeah, no, they've definitely been downplayed, and I think you're potentially leading to the supposed nocebo effect, in which, and I've seen now doctors say that the adverse effects are all in your head. And it's interesting, Steve Nissen, who is the chair of cardiology at the Cleveland Clinic, is on a statin. And he actually reports no, he said it's not in his head. He really got some severe muscle pain from taking a statin. And he tried to lower his dose. He tried different statins. This is a very much real effect. Statins have adverse effects on, probably noticeable adverse effects on about half of the people that are taking it. And so they have conducted studies which I think are terribly flawed. The nocebo effect is this idea that You are told that there's going to be an adverse effect. Therefore, you report an adverse effect. So someone puts this idea in your mind that you can have an adverse effect. That is the nocebo effect. And the way they do this is they have people who already have had adverse effects. And they put them in this study, and they take them off their statin, and they give them a placebo. And now the question is, well, do you still report adverse effect? And they will still report that they have muscle pain. Then you put them back on the statin for a month and take them off the statin for a month. The real problem with this study is the statin adverse effects don't just go away the day you stop taking statins. There's very good evidence that the statin adverse effects will persist after you stop taking the statins. And sometimes, they may very well persist for years. And so this idea that you can simply stop giving someone the statin, give them a placebo, and then ask them the next day, do you still have an adverse effect? And if they report, yes, they do, then you can trivialize this reporting by saying, well, you see that? They have a placebo, therefore it's not real. Well, what these studies don't take into account is the persistence of the statin adverse effects. Now, had I been involved in doing that study, I would have had a group be off the statins for at least 6 months and have them on the placebo. Give it time to wash out. But they never did that. They didn't have people off the statin for more than a month or two until they then put them back on the statin, and then they're asking them if they have adverse effects. So as far as I'm concerned, the nocebo effect has never been shown adequately in people.
Could you comment on those studies that have shown that statins increase the amount of calcified plaque in the arteries, which is obviously incredibly ironic and incredibly tragic at the same time?
Well, this is a great story. I'm glad you asked me about this. So calcified arteries are a very well-established risk factor for heart disease. I mean, there is no other single marker that predicts the likelihood of having a heart attack in the next 10 years. Everyone agrees that a high calcium score is something to be alarmed about. Well, some years ago, this is going back over 20 years, some years ago, studies came out that have now pretty well shown, a bit confirmed, that statins increase coronary calcium. And I can imagine the statin advocates now were faced with a problem. Well, on the one hand, we know that calcified arteries are unhealthy. On the other hand, we have statins increasing calcified arteries. What do? Well, let's turn this into a positive. And what the statin advocates have said, that this is a good thing, that statins increase coronary calcium. And their view is that by increasing the coronary calcium, this stabilizes the plaque, makes it less likely to rupture. Well, I want to be polite about this, but there are a lot of ways I could describe this that have to do with feces coming from bulls. I mean, it's absurd to think that you could actually do something with a drug that's known to cause harm and turn it into a benefit. Isn't that great? We can get more calcium into the artery so we can stabilize the plaques. No, this is clearly unhealthy. Now, if they conduct the studies long enough, it is likely that you will see an association that between the increased calcified arteries and harm. But these studies are conducted only for typically 2, 3, 4 years. And so you're not really able to compare to a placebo to actually see the negative outcome with the increased calcified arteries.
So you've been researching cholesterol and statins for 14 or 15 years now? And
Well, 15 years, yes. Well, since 2007.
Have you seen a change in the opinions of your colleagues during that time?
Yeah, that's a great question. So going back in the beginning, and I remember talking to an MD at first about how high cholesterol may not be causing heart disease when I first started learning about it. And he said, well, everybody knows cholesterol causes heart disease. It was dogma. It was accepted fact. It was very tough to find any physician that would even be amenable to talking about the possibility that cholesterol didn't cause heart disease. The times, they really are changing. I'm on Twitter regularly, and there are just so many MDs that come to me and thank me and MDs that themselves are conducting research. MDs that I'm working with now that I'm so impressed with. Like, these are real scholars, these MDs. And the research that's being conducted, in particular, looking at low carbohydrate diet. And now people are addressing the possibility that an increase in cholesterol with low carbohydrate diet is not hazardous. This, I don't think, would have been acceptable a decade ago. And so I really see that things are changing. There are now so many conferences put on for metabolic health, for low carbohydrate diet, in which people are routinely talking about all the great benefits of lowering carbohydrate consumption, which improves essentially all biomarkers. And the only thing left is that in a subset of people, you have an increase in cholesterol. And so many physicians now have come to me and now are publishing papers saying this is really not a great concern. So yes, things are really changing.
And what is it that has kept the cholesterol hypothesis going up until this point? Is it simply the commercial interests?
Commercial interests are powerful. If you think about it, look around. It's not just the pharmaceutical companies. How do you sell Cheerios? The answer to the Cheerios are that it's heart healthy, supposedly because Cheerios will lower your cholesterol. Think of corn oil. Corn oil does lower your cholesterol, and that's why it's heart healthy. And in fact, there's a study going back 50 years ago, which people who consume more corn oil, who have heart disease, had a significantly higher rate of heart attacks and death. So corn oil has actually never been shown to benefit anyone's heart, but it does lower cholesterol. There are herbs and nuts and seeds, all of which can lower your cholesterol. So realize the food industry depends on demonizing cholesterol. And now you have a great wave of pro-vegetarian groups. And the interesting thing is, when people become vegetarian, the only real marker that changes is cholesterol. And you do see universally, when people become vegetarian, their cholesterol declines. And this is therefore promoted by the vegetarian industry. So it's clearly commercial interests that profit. Now, in addition to statins, there have been new drugs that have come down the pipeline. Relatively newer, the PCSK9 inhibitors, which cause a huge drop in LDL cholesterol. And so when people become statin intolerant, they're put on these PCSK9 inhibitors. You've also got other drugs coming down the pipeline. It's relatively easy to lower LDL levels. And so a variety of different drugs. And they're even now manipulating people's DNA to lower their LDL for a lifetime, which I consider frightening. And so there are multiple levels, all ultimately funneled into maximizing profit and, to me, having absolutely no benefit to people's health, that have maintained the cholesterol hypothesis.
And would you say that medicine in general has become too focused on risk factors? I think we see this in particular with cardiovascular disease, where it seems like just a handful of numbers are put into a simple calculator, and then a magic number comes out of that, as which is supposed to be an accurate prediction of someone's risk for a heart attack. Is this model really appropriate?
Well, I do value biomarkers. And in fact, it was the biomarker that I learned of, 25 years ago, the high triglycerides, that told me that I was unhealthy. So I don't dismiss biomarkers, and I don't dismiss strategies to improve certain biomarkers. So we need to know which biomarkers are crucial for telling us about our current health and the future likelihood of having a disease, whether it's cancer, Alzheimer's, or heart disease. The biomarkers that really matter, and you may not be aware of it. Sometimes having hypertension or high blood sugar or high small dense LDL, you may not be aware of it. I was a bit overweight, but I had no idea my triglycerides were high. You can't feel having low HDL. And you could sort of get used to being a bit overweight and think that it's okay. So I think that what's important is to measure the biomarkers that matter. And then, to me, the first thing that people should do is to change their lifestyle, change their diet. A person that has high blood sugar, it's so easy. Now, frankly, I know many people who turn to medication first. I know doctors who prefer medication. Of course, they'll say you should change your diet and lifestyle, and they say, when that fails, I've got the pill for you. And it's so easy for people to depend on medication. I have a friend who just told me she would rather take semaglutide rather than lower her carbohydrates. And so it's so easy to take a pill because fundamentally we're lazy creatures. Who wants to have to start exercising if you don't enjoy it? Who wants to cut out carbohydrates? Who wants to cut out the dessert? If you can take a pill that'll give you good health, it's so incredibly appealing. But I give people the bad news, which is you just don't find good health in a pill. And so I do believe we should use the biomarkers that matter and have that guide the change in our lifestyle and diet.
Professor Diamond, thank you very much for taking the time to share this important information. I would also, you mentioned Uf Ravenscoff a couple of times, and I would also like to give him credit because if it wasn't for his book, The Cholesterol Myths, the original and classic text on the subject, I also would not have become aware of these important issues. And it's because of his book that led me to make the 2 documentary films as well. So I think it's important to acknowledge his really important contribution.
Yeah, I thank you for inviting me to be on your podcast. And Uf Ravenscoff has really been a mentor to me, motivator. We published together, and he's been a force on our side on the war against cholesterol.
And how can people follow you? You mentioned Twitter. Is that the best place people can follow you and get in contact with you?
So first, I'm on Twitter. My username is LDL Skeptic. Second, I've been able now to, I think, make a difference. I've worked with physicians now and others, and we're starting a company called HealthQuest. And what we want to do is find the physicians that look at lifestyle and diet first, and we want to help people by using real evidence-based medicine. So we've started a Facebook group called HealthQuest, and I would welcome people to be invited to be part of this. Ultimately, we want to have people take charge of their health through this organization, which we call HealthQuest. I'm the director of the science and research for this organization. So I believe through this organization and my almost daily Twitter comments, I think people can get a whole lot of really good evidence-based information.
Excellent. Thank you very much.
All right. Thank you, Justin.
Thanks for listening to this episode of The Self-Sovereign. If you found it interesting or useful, then subscribe to the podcast and share it with others. Also, please check out the links in the description, which are related to what was discussed today. And don't forget to leave a comment and let us know what you think about this important subject.